Student, today we will learn the chapter probability and probability distribution, part 4. Okay student, now before I will describe something more about total probability and Bayes theorem, you should learn something using of and or by this to some questions. Let the one question is, if there are two speakers A and B, okay student, A speaks true, the probability of this is let 1 by 3, and B speaks true, that is the probability of is let 1 by 4. Now if the question is on a point, if they want to be discussed to each other, then they agree of that discussion point, then find out that probability of agreement. This you can understand this way. If here is some pen, that here is a pen, and this pen is described by A. Let he speaks true that this one is a pen, then he had to be say true, then probability of speaking is true is this one. If B is agree, then he also say true that yes, it is pen. Okay, both are saying true for agreement. So and this will also say true. Okay, but it may be happened that A want to be say lie that it is not a pen. It is a pen, but he want to be say that it is not a pen. If B want to be agree, then he also say that lie. So he will lie means not truth, and it is also not truth. So this may be happen, or they are both true and they are both tells lie about this pen. Okay, so this way this total event is probability of agreement. Now we can say this value is 1 by 3 into 1 by 4, this for and this for and or. So we can say this is 1 minus 1 by 3 into 1 minus 1 by 4. So this you can solve very well. Okay. So we can say the answer of P agreement is 1 by 12 plus 6 by 12. One by 12 plus 6 by 12, it is 7 by 12. Now if they are not agree, then it is 1 minus probability of agreement, that is 1 minus 7 by 12 is 5 by 12. So I am using here agreement here and or. I am using what for and multiplied and or for plus. So now I want to be described one very important questions, that here is a here is a 9 person in which 4 are boys and 5 are girls. Okay. Now you want to take a committee for 4 persons. You want to take a committee of 4 persons. So what is the probability of committee of 4 persons? 4 persons, you have to want to be the probability of getting the committee of 4 persons. Committee of 4 persons. Now, if this is the conditions that exactly 2 boys, so you have to first select 2 boys and rest 2 members you have to select from 2 girls from 5 girls. Total you have selected 4 members from 5 plus 4 9 members, 9C2. This you have to solve. And you know the formula NCR is factorial n upon factorial r factorial n minus r. Using this formula you can solve this very well. So you can solve it. Okay. So that is 4 into 3 upon factorial 2, 5 into 4 upon factorial 2 upon 9 into 8 upon factorial 2. So this we can solve 4 into 3 upon factorial 2 means into 5 into 4 upon 2 into 1 and factorial 2 upon 9 into 8. So this you can cancel out and rest you can solve yourself. Then this will be your answer. Okay, rest you can solve yourself. Okay, now if you want to find a committee of 4 persons, not exactly 2 boys, let at least 2 boys. Committee of 4 person where at least 2 boys. So what you have to do, in 4 person you have to select 2 boys and rest 2 girls, or you have to select 3 boys and rest 1 girl, or you have to select 4 boys and rest no girls. So this way you use the formula of and here is or, and total you have to select 4 members from 9. So now you can continuation you can solve this, then this will be your answer. Okay, this way it is a very important formula for and or. Now I want to tell you something more. Now that here is a sample space of, when you roll the dice, that is 1 2 3 4 5 6. Okay, that here is a event 1, later is 1 2 3, and here is second event, that here is a 4, and third event, that it is 5 6. Now you can see here is intersection in all event is 5, and if this is 5 means these all event are intersection is 5. Okay, these events are subset from this S. Okay student, then these are known as exclusive event. Exclusive event means, what are the exclusive event? If their intersections are 5, okay, then they are exclusive event. Now you can see here also E1 union E2 union E3 is 1 2 3 4 5 6 equal to sample set. Then this event is known as exhaustive event. exhaustive event. It means these are very two important event, exclusive and exhaustive event. It may be in number of subset. When you find it, it may be exclusive and exhaustive. It may be not exclusive, not exhaustive. It may be both are not exclusive and exhaustive. Okay, when intersection is phi, then it is exclusive. When union is sample space, then it is exhaustive event. Okay, student. Now I am going to be talking about total probability. This total probability you will better understand by a following examples. Let you are on a bicycle and carrying a bag. Here are 3 bags separately. Both are of the same color. So let in first bag, in this bag, 4 red ball and 3 blue ball. In the second bag, there is 5 red ball, 4 blue ball. And a third, 3 red ball, let 5 blue ball. Here are 4 red, 3 blue, 5 red, 4 blue, and 3 red, 5 blue balls. Okay. At a time, one red ball is drawn from any bag. Not is drawn, red ball is fell down. Let one red ball is comes out from any bag. So what you have to think? You have to think one red ball may be from this bag, or maybe from this bag. Red ball may be from any bag. Here you can see the all events are exclusive and all events are exhaustive. When the events are exclusive and exhaustive, then we can say find the total probability. What is the meaning of the total probability is that red ball here coming from this bag, or maybe come from this bag, or maybe come from this bag. Okay, let this bag is A and this bag is B and this bag is C. The selection of this bag is PA. Probability of selection of this bag is PA. When you have select this bag A, then from this bag you have to take the red ball. Okay, so it is a conditional probability. First choose the first bag and then taking the red ball from that bag. Or it may be happen you have to take the second bag B, and then conditional of this bag you can check the red ball for B bag. Okay, similarly you can say you can check the third bag, and from third bag you can check the red ball from third bag. This total red ball, when you find out, that is the total probability of coming of red ball. So this way, coming of red ball, you can find the total probability of sum of these all. There is no chance you have to left red ball maybe from any bag. Okay. So this total is known as total probability. Now, if we want to be solve it, then what will you answer? That is choice of first bag A, that is 1 by 3, and choice of red ball from first bag, that we are seeing here, 4C1 upon 7C1. Total ball are 7, select one ball, and red ball is 4C1, you select one ball. Okay, so that is, we can say 4C1 upon 7C1. Now select the B bag. Again total probability is 1 by 3. From 3 bag you select the 1 bag, and now there is 5C1 from 9C1. 5C1 upon 9C1. Selection of third bag, and coming the red ball, 3C1 upon 8C1. Okay, now when you solve n is C1, that is n, so here is 4 upon 7 plus 1 by 3 into 5 upon 9 plus 1 by 3 into 3 upon 8. So after going through calculation it, you can find out your answer of getting the total probability. Okay, now this one is the total probability. So using this you can solve so many questions. Now I am talking about using this again examples, that is the Bayes theorem. Now according to Bayes theorem, if we want to find the red ball from A bag, means number of required event upon number of total event. Using this formula we can say number of required event will be from A bag, that is PA into PR upon A, and here is coming of red ball, that is the total. Okay, this is the Bayes theorem. If we want to know from second bag, B bag, then here we can write this number and this is total, and from C bag this we can write this number and this one is total. So this is a required event and this is a total event. It work as this using this formula. Okay, so main formula is this one, this way. This work as a required event and this work as a total event. So we can calculate this taking this one and taking or this one. Okay, so we can solve this and you can solve also yourself. Okay, student. So we can write here the value here, and 1 by 3 into 4 by 7 upon 1 by 3 into 4 by 7 plus 1 by 3 into 5 by 9 plus 1 by 3 into 3 by 8. Now you can solve this. So student, using the Bayes theorem, if you want to know some things from a particular bag, so we can use the Bayes theorem. Now you can take an example here. Here is a factory. That here is a factory and it starts from January to December. It may be possible that in some time it may be strike. Okay, the probability of strike is let 1 by 3. But work is going on. A little work in this time when the strike is going on, and some more work when the work is going on in a required situation, means no strike. So let probability of strike is 1 by 3. So mean probability of not strike is 1 minus 1 by 3 is 2 by 3. Okay. Now let on the strike time, probability of work on the strike time is let 2 by 3. Therefore, no work, no strike time, the probability of work is, that is 1 minus 2 by 3 is 1 by 3. So now the question is probability of getting work at strike time. So we can write probability of getting work when strike is going on. Okay, so work are here two times. When the probability of getting strike, then the work is going on. If probability when the strike is not coming, then the work is going on. Okay, student. So this way we can solve these things. 1 by 3 into 2 by 3 upon 1 by 3 into 2 by 3 plus 2 by 3 into 1 by 3. So you can solve this and get the answers. This way you can use the Bayes theorem. Okay, students. So if you want to go to the practice, you have to use some books and solve some more questions. Okay, students. So in the next video, next part 5, I will describe the distribution. Thank you.